Today's session is File Preparation for Specialty Inkjet Printing. It is my pleasure to introduce our speakers for today. Carrie Maloney, Field and Channel Marketing Manager for Fiery Wide Format. John Nate, Worldwide Technical Product Training Manager for Fiery Wide Format. So with that, let's begin. Carrie, take it away.
Thank you, Yael. So on today's session, we'll explore the subject of file preparation for specialty inkjet printing. First, however, I'd like to define what specialty printing actually is. Well, in the context of today's session, specialty printing is really anything above and beyond regular Gamut CMYK printing. So any job requiring spot colors or special inks perhaps, or that requires a larger gamut maybe. Anything that's wide or super wide, or even jobs that need to be prepared for another process after they're printed. So why do we need specialty printing? Why does it exist? Specialty printing gives us superior, more versatile, and more vibrant and more impressive printed results. Specialty printing is also the key to creating accurate prototypes and mock-ups for many industries. But regardless of the industry or application, specialty printing always starts with correct file preparation. So today we'll cover key aspects of file preparation, the use of different applications and file types, through to working with spot colors, layers, paths, and specialty inks, and more. Before we make a start, we'd like to see what types of work our audience create, and on which technologies they use. So we'll take a quick poll. You'll now see 2 questions on your screen. You can choose more than one option per question, and we'll give you a moment to complete these. Okay, thank you. I'll now hand you over to John Nate to take you through file preparation for specialty inkjet printing.
Thank you very much, Carrie, and thank you, y'all. Welcome, everyone, to today's session on specialty printing. A little more detail before we get going on what I'm going to cover today. I'm going to talk a little bit about the software that we use to prepare the files for specialty printing, the most common ones. Certainly you're not limited to the ones that we'll necessarily be covering here. The type of file that you'll want to save for specialty printing, and an often overlooked aspect of specialty printing, and that is the required file resolution, the size, the DPI of the images that are part of the graphical display. And you might kind of find some surprising answers as we go through that area of today's session. Next up is covering spot colors. How do we make sure that our spot colors are as accurately reproduced as possible? And specialty inks is up next. White ink, silver ink, any of the specialty inks that might be available on today's inkjet printers. Years ago, all we had was cyan, magenta, yellow, black. Then we added light inks. Then we added orange, green, red, blue, additional inks for wider gamut printing to give us better spot color resolution. And recently we've seen the advent of clear and white and metallic inks, which greatly improves the capabilities and expands the capabilities of what we can get off of our inkjet printers today. So we'll cover silver, white, and clear, how we prepare our file to make sure that those are properly recognized for our output device. Wide gamut printing. Wide gamut printing or full gamut printing, getting that last little bit of color out of our output device, where we're not necessarily as concerned with matching the brochure off of an offset press that is running traditional CMYK to a standard such as ISO-coded or Grackle, but instead, because we've got larger gamuts on many of our output devices, making use of that gamut, not just for spot colors, but for the traditional process portion of the graphic also. How about cutting? Cutting is an area where we've seen a lot of people make mistakes in their file preparation. So I want to delve into details on what's required there. And finally, pre-flighting and repairing. How can we make sure that the file coming into our office or that we're sending to our production facility is correct, and what kind of repairs can we do if the content creator did not really prepare the file in the right way in the first place? Okay, but first, a little more detail of what specialty printing is. Carrie made mention of some of the aspects of specialty printing, but let's take a look at some examples. Well, some examples are building wraps, these large graphics, multi-panel graphics that cover the entire sides of buildings. I see these often when I head out to California and see all the new movie posters that are covering the sides of buildings. Billboards, which I'm sure we're also familiar with. Now, one newer area, and it's a newer area for EFI also, is ceramic tiles. We can now inkjet print onto ceramic tile material before it goes through the kiln and is prepared for installation in our final facilities. Kind of a growth area for us is ceramic tiles. Day-night backlit. So a display that works both during the day when it's front lit by the sun and at night backlit by some type of illumination. So no matter where or when you are walking past the store or the facility, the graphic has that pop, that snap. Vehicle graphics, anything from trains to buses. I've seen airplanes with vehicle wraps. Window graphics, often these are also day-night graphics, but not necessarily. Sometimes they're only backlit, sometimes they're only front-lit, but can often be quite large. Floor graphics, printing on a very durable material that can be walked on for days, weeks on end, and still hold up and look just as stunning as it did when it came off of the inkjet printer on day one. And then we get into the area of the special inks. We've got our spot colors where I want that particular color to be as accurate as possible. It may be part of the corporate identity. It could be a logo color. It could be just a special color that the designer selected that he or she wanted to be reproduced as accurately as possible on the output device. It's an area where we often get calls at EFI in our support that my spot color is not reproducing correctly, and often it's a very, very simple fix because of the fact that the file was actually not prepared correctly. Then in addition, we have metallic ink, we have white ink. Now we're adding clear ink to do the effect of spot varnishes that we're used to seeing on traditional offset printing presses. And into some really specialty printing examples, we're now seeing inkjet printing onto membrane material, where that is actually the final piece that's installed on the control unit. Shrink wrap, where it could be a prototype or it could be an actual label run where this is actually the final product coming off of the inkjet printer. And even braille printing, there are printers out there that can print multiple layers to build up dimension to print braille. Okay, so how do we do this? What do we work with? Well, let's take a look at the software, what file type we should be using, and how big we should really be making these graphics. And when I say big, I mean file resolution, not literally the size of the output itself. First of all, let's talk about vector versus raster. Now, vector is the type of graphic that is generated from a software package such as Adobe Illustrator or Corel Draw. It is literally a drawing, an illustration, a kind of a connect the dots type of graphic. And the output, when you're dealing with vector files, is device dependent. Now what I mean by device dependent is that the quality depends upon the output device, the quality of the device, the resolution you're printing at. A little more detail on that in just a bit. But the second type of graphic we deal with is raster graphics, sometimes called bitmaps, TIFF files, JPEGs. These images, the final quality is dependent upon the document itself, the image itself. Okay, well, let's take a little closer look at that. First of all, vector. I've got an image here, our little fiery logo, and if you look, our little registered trademark, and if I zoom in, I see this little part of the R, and if I zoom in there and enlarge that even more, it still looks just as good. That's because a vector illustration it's based on math. It's kind of formulas and instructions. And it will take advantage of the quality, the resolution of the output device to make it look as good as it can on that output device at that size, at that resolution. That's why, if possible, you do not want to convert your vector graphics to raster. As soon as you convert a vector graphic to raster, you have locked in the quality. Okay? If you enlarge it greatly on the output device, the output quality is going to suffer. So you want to keep vector graphics as vector as long as possible. How about raster? Again, the quality, as I said earlier, is file dependent. If you take a look here, here's a little boat on this image, and if we zoom in on the boat, well, it still kind of looks like a boat, but now if I take this little area and enlarge that, well, now you can see we've got all the little jaggies and JPEG artifacts and all sorts of issues with that file. It is not just as good. It's not just as recognizable as a boat or a section of a boat as it was in the original document. So the larger we make this, really kind of the lower the inherent or the effective quality is of the image. So you want to make sure your raster files are the correct size, the correct resolution. So our software options, what options do we have? Well, for images, for our raster files, probably the most common out there is Adobe Photoshop. Photoshop Elements in Adobe Lightroom, kind of some more limited versions of the Photoshop program, not quite all of the capabilities. Corel Paint Shop Pro, common program for people that work a lot on the Windows side. Although Photoshop is available on Windows, Corel Paint Shop Pro is a program that we often see from the Corel suite that people are using on the Windows side. Now for vector images, Adobe Illustrator, probably, again, the market winner right now, but Adobe InDesign can also be used. Now, Adobe Illustrator is used to create the graphics. Adobe InDesign would be used to compile the final document, where you bring in the images from Illustrator, the images from Photoshop, the add fonts, things like that. And InDesign is a more efficient program to use for doing that final assembly. Although a lot of people will do their assembly in Illustrator, some might even do assembly in Photoshop, although because of the problem with the built-in resolution and the possibility of rasterizing your logos, your text, things like that, tend to recommend staying away from Photoshop for final assembly, if possible something like InDesign or Corel Draw on the Windows side again. So a lot of software options, and they're all perfectly capable of producing the type of graphics most people need to put together. But now for the full production, you're going to use multiple software packages likely. To produce raster elements, might use Photoshop and output them as TIFF, sometimes PSD files. I'll cover that in just a little bit. Create complex vector elements, your logos, your drawings, in something like Illustrator, output as either EPS or PDF files, and then final assembly of the artwork in something like InDesign. And then generate the final output as a composite PDF file without downsampling the images. Now, downsampling the images is more of an issue if you're printing an output that's small, where the DPI might be brought down to a lower resolution. But you want to be careful also that you don't downsample anything that is going very, very large. Again, I usually recommend turn downsampling off when you're generating your PDF files. Just keep all the resolution you can. Storage space is cheap these days. We're no longer worried about, oh, I've got my small hard drive and they're so expensive and it's almost full, so I'm going to compress these files and downsample my images. We don't want to worry. We don't need to worry about that anymore. Hard drives are dirt cheap. Storage space is very, very inexpensive now. So keep the resolution there. Even if you're not going to use the resolution today on this particular graphic, you know what? 6 months from now, your customer might want something much larger. And if you've downsampled the image, well, now you've already damaged the image. So keep the images as large as possible. So file format output. Now we know what software packages we're going to use. For raster images, recommend either TIFF or PSD files if you're working in layers. Okay? I recommend staying away from JPEG files. JPEG files create something called JPEG artifacts. JPEG artifacts can be seen maybe a little bit here. I'm going to take this area of the image and zoom in a little bit. This is actually a TIFF file, and this is a JPEG version of the image, and you can start to see some of the problems around the fonts. But if I zoom in, you get a much better idea. You can see these kind of large squares. What JPEG compression does is JPEG compression takes areas where pixels are awfully close to being the same, and it makes them the same, because then it can kind of use shorthand when it saves the file and actually make a smaller file out of the original file. But as you can see, this damages the image. The larger this is going to go, the more noticeable these JPEG artifacts are going to be. Also, what a lot of people don't realize is that if you open up a file that is a JPEG that has compression artifacts and you do any work on it and you save it as a new file, and you have JPEG compression turned on, it's going to JPEG compress your JPEG compressed file and add even more artifacts to the file. So I recommend staying away from JPEG if at all possible. I recommend using TIFF files. Now, TIFF files are very, very handy. You can save your files as RGB, CMYK, or LAB. Now, any of you that aren't familiar with the LAB space, at the end of our presentation today and on the documents you'll be able to download, there's going to be a link to the color series of webinars that we produced earlier this year. And in there we cover issues of color management, but also file types, and cover this LAB color space in detail. So if you're a little unfamiliar with maybe some of the benefits of working in LAB or RGB, go take a look at the other webinars that we have stored. You can embed an ICC profile in your TIFF files. Now that means you could have multiple TIFF files with multiple color space profiles assigned to them. And if your RIP, your output device, is configured properly, it can make use of those ICC profiles and really correct each image the best it can, rather than trying to do like a blanket. We're going to do everything to ISO code it or everything to swap, or we're going to just make assumptions. It won't necessarily make assumptions. It will do the best job it can of each individual image. And for TIFF files, if you want to save some file space, you can still use compression, but we have the ability of using lossless compression. Lossless compression, LZW or zip, again, stay away from JPEG, but LZW or zip compression is lossless. It won't get the file as small as it will with JPEG compression, but yet it will save file space, but you won't get those annoying artifacts. So it gives you a much, much better output. Now, another option for your images would be a PSD file. And a PSD file also can support the RGB, CMYK, or LAB color space. You can also embed ICC profiles. Okay, so far this is the same as a TIFF file. Here's the difference. You can save a PSD document with layers. And if the output system, the RIP that drives the Inkjet printer, can understand files with layers in it, you're going to be able to do the prep work for your specialty printing. Now, layers could be cut paths. Layers could be additional spot color or specialty ink channels, your silver, your whites, etc. So layers can be very, very important when you're working for specialty printing. And if this is the case, you're probably going to want to save your files as PSD files. Take a little close-up look at this in just a little bit. Now, moving on to vector. For vector and or vector that might have raster images in them also, you want to save as EPS or PDF files. Either seems to work fine for most people, so a few less options there. However, if you decide on PDF, and let's face it, the world pretty much has moved in the direction of PDF, all PDF files are not created equal. Your choices are really going to be one of two: PDF, X1A. X1A is kind of the sub-flavor of the PDF file. So what does X1A mean? Well, that means it's the least flexible file. And by least flexible, I mean that it can only support CMYK color space. So if you have images in RGB, they're going to have to be converted to CMYK in order to be saved as a PDF X1A. Okay? No ICC profiles are allowed in PDF X1A. No transparency, no layers. So as you can see, it's somewhat of a limiting flavor of PDF, but it's the least likely to cause reproduction problems. Companies that run offset printing presses running only our traditional 4-color inks quite often would prefer their files to be delivered as PDF files in PDF X1A format because they don't have to worry about file conversions because there aren't RGB or LAB. They don't have to worry about ICC profiles getting in the way because ICC profiles can be treated differently in their proofing RIP versus their RIP that drives the plate setter or the image setter or the digital press. So they could get a proof-to-press match that is not the same because ICC profiles got in the way. And no transparency or layers, so everything has to be flattened. Your second option, PDF X4. This is going to be your option most often for your specialty printing. It is the most flexible form of PDF file. Now, I've stayed away from the forms of PDF that allow you to add audio, video, do forms. I'm strictly talking here about flexibility from the traditional or inkjet printing stance. PDF X4 supports CMYK, RGB, grayscale, and spot colors. ICC profiles are allowed, so we can have a lot of flexibility in how we build our files, and transparency and layers are allowed. So if you have layers, if you have additional spot colors, if you have cut paths, white ink, clear ink, metallic, you are certainly going to want to save the PDF file as a PDF X4. Okay? However, this is most likely to cause reproduction problems. You have to make sure that the output system is capable of properly rendering your PDF X4 files. Well, is that even possible? It certainly is, and towards the tail end of our presentation, we will tell you how to do that. So how do I set this? Well, in InDesign, if you go to File, Adobe PDF Presets Define, you'll see this window. I've zoomed in a little bit here, and here you can see all the PDFX flavors. PDF X1A, and there's our PDF X4. So you simply select the preset before you generate your PDF file. In Illustrator, and these are just two examples, I'm just using InDesign and Illustrator, File, Save As, and then Adobe PDF. Here's a little custom drop-down and our standard. And under standard, you can select PDF X4 in this case. So now I'm ready to go from Illustrator with saving my file with layers, with ICC profiles embedded, with different color spaces, and I am set to go. Again, you want to save as PDF X4 because you want to save the file with as much capability, as much value in it as possible. If you know you're going to make an output that's going to be used for a brochure, and you downsize your images and you convert them all to swap because that's what the final output is going to be printed on, or ISO uncoded, or one of the FOGRA standards, well, then if all of a sudden your customer turns around and says, my goodness, that brochure looks great, we're going to the big trade show and we want a multi-panel output, you may have to go back and recreate the file. Okay? But if you saved it as PDF X4 and kept the correct resolution, much more likely that you could just go to that final output. So we're going to look at a file preparation checklist as we go through today's presentation. So first of all, we've got the proper file format, TIFF or PSD if you're working with layers out of your image editing program, EPS or PDF out of your illustration program. Put them all together and save them as a PDF X4 file. Okay, well, how about file resolution? An often overlooked situation. You often see images reproduced in magazines where they're just horrible as far as resolution. Now, this becomes even more of a problem when you're printing something the size of a building. Now, in the proofing world, we're used to talking about, over here in the States, 8.5 by 11 size documents, and standard rule of thumb was always 300 DPI, which gives us a 32 megabyte file. if anyone has ever wondered where 300 dpi came from, the usual output was that we wanted to have 2 pixels or 2 points in our image for our dot on the press. That seemed to be good quality. Any more than that, and you didn't really gain anything, you just wasted space. A lot of printing was done 133, 150 line screen, so you double that, and that gives you your 300 dpi. That's kind of where that came from. We're talking specialty printing, and often we're talking about large production pieces. If I take this 12-foot by 40-foot billboard, and I make this display 300 dpi, well, now I've got a 23 gigabyte file. So hopefully if I make this as an attachment to my email before I send it to you for reproduction, we've got a pretty big pipeline so that it gets there within a week or so. Is that resolution necessary? It is not, and you might be surprised at what resolution we need. Now, to find the file resolution, what you need, there's a couple of rules of thumb that are used quite often in the industry. I'm going to go through these, and there's some math involved in here. You want to start by determining the standard viewing distance, and you either have to measure it, and it's 1.5 times the diagonal. So measure that diagonal. Not quite so easy if you have to climb up on the billboard. You have to measure it or do some math. So I'm sorry, there is some math involved. However, there's light at the end of the tunnel for any of you that did not get involved in the graphic arts industry because you were so darn good at math. You know, you just excelled in trigonometry and advanced calculus in high school, so you said, by gosh, I'm going to go become a graphic artist because I'm really good at this math stuff. Well, for those of us that maybe aren't, I've put together a little mini spreadsheet that you're going to be able to download, and you can just simply enter in the dimensions of the document, and it will tell you what the resolution is that you would need, the minimum resolution for your displays. But I want to go through exactly how this is calculated so you understand what's going on. I hate these little black boxes that just says, hey, enter a number and magically some result appears and we're not going to tell you how we got there. Well, I'm going to tell you how we got there. So we want to come with 1.5 times the diagonal. Well, if I don't know, I should know the length of the document. In this case, it's 40 feet. So I multiply that by itself. 40 feet by 40 feet gives me 1,600. So far, math is pretty easy. Height, the height of the document. Well, I've got 12 feet tall. Multiply that by itself. 12 times 12, 144. Again, so far, math not too much of a problem. You add the two values together, the 1,600 plus the 144, and that gives you 1,744. Okay, what do we do with that? Well, in our little calculator, you press the little square root key, and that will give you magically that diagonal. So instead of going up there and measuring, we simply doubled the width, doubled the height, added them together, hit that little square root key, and it comes up with 42 feet, our diagonal. Multiply that by 1.5, gives us 63 feet. That is considered standard viewing distance. Standard viewing distance is 1.5 times the diagonal. Traditionally, that's as close as someone should stand when they're evaluating the quality of the image. Okay, so now we know standard viewing distance, so how does that help me figure out what resolution my document should be? Well, if we take the standard viewing distance and convert it into inches, and again, this is all going to be done for you automatically in the little spreadsheet, so don't worry about it. I've got 756 inches. If I take 756 inches and divide it into this magic number that scientists and graphic arts design investigators have come up with over the years, divide the standard viewing distance in inches into that magic number, it gives me my file resolution in dots per inch or pixels per inch, however you want to define it. So in this case, my 3438 magic number divided by 756 is 5 pixels per inch. So my illustration only needs to be 5 pixels per inch for my billboard. 5 pixels per inch, seriously, can it be that low of a resolution? Well, let's take a look. Here's a 5 pixel per inch image, and on your monitors you should be able to see, the individual pixels here, and on your screen look at about 5 of these, and depending upon the size of your monitor, 22-inch monitor, somewhere in there, that should be about 1 inch worth of image. And you might look at this and go, well, this does not look good at all at 5 pixels per inch. As a matter of fact, it looks pretty awful. Okay, how about this image? This image looks pretty good. Well, this is my 12 by 40 foot billboard aspect ratio. And the image is 5 dpi at that size. Well, this looks pretty good. The prior screen was this portion of the image just simply blown up. Okay? Now, as a little experiment, take a look on your monitor and look at the diagonal here and kind of see how big that looks. And move your head about 1.5 times that length away from the screen. Does the image look good? That's how a billboard would look at 5 dpi from 43 feet away. It actually does work. And add to that that you might be driving past it at 100 kilometers an hour, and resolution becomes a little less of an issue also. So does this work for everything? If I take my 8.5 by 11 inch document, double that, or multiply that by itself, add them together. Standard viewing distance for my little brochure would be 14 inches. Divided into my magic number is 245 pixels per inch, dots per inch. And again, if I do 133 times 1.5 or 2, that's 200 to 266. Yeah, that actually does work. It's right within that formula. So whether it's small or large, this formula actually does work. Okay. Now, large format file resolution, you still want to check with your printer. I'll be honest, a lot of them get very, very nervous when you start to talk about very, very low resolution, and it's really almost an urban myth. You know, well, I need bigger resolution, but you'll find I did some research here before putting together this presentation, and 9 pixels per inch was actually, you know, quite typical in what people said they were receiving, and 8 to 25 was very, very common for large display work. This is actually the calculator, the spreadsheet that you're going to be able to download, and I've got it set as feet, height and width in feet, or height and width in meters. And you just plug in those two numbers, and your minimum, and I stress minimum DPI, will appear in the window. You still want to contact your display printer for confirmation before generating the final artwork. Okay? Now, we still have size limitations in our documents too, so we have to be a little careful there. Adobe Illustrator only allows us to make a 227 plus change size document. Well, that's only 18 feet by 18 feet. I can't do my 12 by 40 foot billboard to size in Illustrator. How about InDesign? That's even smaller. Nope, can't do it there either. Corel Draw wins. Corel Draw 150 feet by 150 feet. So I could do it full size in Corel Draw if I wanted to. But if I'm going to be using Adobe Acrobat anywhere in my workflow, if I save it as Adobe Acrobat 4, that only allows a 45 inch by 45 inch final document size. 5 is 200 by 200 inches. Well, finally, 6 caught up 15 million inches by 15 million inches. So Acrobat 7 will work, but a lot of people want to save it as prior versions just to make sure that it's compatible with other versions of Acrobat for viewing. Distiller also, if we generate a PostScript file and generate our PDF using Acrobat Distiller, that limitation is the Adobe Acrobat 5 size of 200 by 200 inches. So what's an artist to do? Well, work at half, quarter, or 1/8 size. So if I decide I'm going to work at quarter size for my billboard, that means I'm 144 inches by 440 inches, doing my little math with my little calculator. Hey, 36 inches by 120 inches. That works in Illustrator, works in InDesign, works in Acrobat, so I am fine. Use caution. My last little word here on the illustration of the document. If I work on 1/4 size for the document, my raster graphic, my bitmap, my TIFF file has to be 4 times the file size. If I work half size, it has to be double. Okay? Because if I work 1/4 size and this image is then enlarged on my output device to spread it across 4 times the area, That means my pixels are spread across 4 times the area, and they are kind of 1/4 as effective. Okay, I can't just magically make more pixels that way. It just doesn't work. So my raster graphic has to be times 4. If you work at half, quarter, or 1/8 size, don't work at half, quarter, or 1/8 size for your illustration without twice, 4, or 8 times the resolution. Okay, so one caution. So in that case, my 5 dpi image times 4 would be 20 dpi on my 36 by 120 inch image. Okay, here's a real-world example. One of our great customers, Supercolor, built these graphics for Mutual of Omaha. They're on the outside of the Mutual of Omaha building. It's a 45-foot by 200-foot graphic, so not exactly your standard wallet size image. And I'm told the original file was approximately 3 to 4 dpi. For various technical reasons, they resed it up to 10 dpi, the artist did, when they were working on the final display. But originally, and again, just resing something up doesn't magically give you more detail or more information. It just gives you a little, a few more pixels to work with, but no increase in resolution. So that original 3 to 4 dpi. And again, it looks fine from the standard viewing distance. Anybody walking up to the display with their own loop to take a look at the quality is probably going to get their hands slapped. All right, so our file preparation checklist, back to that. We've got the file format that we want, and now we've got the proper image resolution. Okay. If you have any questions, by the way, please feel free to drop them into the question and answer window. We'll answer as many as we can at the end of the presentation today. So spot colors. What's in a name? Probably one of the most common problems we have with spot colors in the technical support area here at EFI. People say, hey, my spot colors did not reproduce properly. Well, if spot colors are properly defined, they can be modified in the RIP, the software that we use at EFI, our Fiery XF, Fiery for Pro Server RIPs, or even the Fiery on the toner side. If it comes through as a spot color, we can work with it. We can modify it. Spot colors should be defined in the RIP as LAB values, and if they are, they're what kind of self-correcting. The RIP generates a new recipe for the proper media. A color is recipe-based. Again, go back to the prior color webinars we did earlier. The recipe needs to be changed for different media. If you ever print on one of your output devices you might have there on different media, you're going to see you get different color on the output. Well, in a RIP, if you have spot colors defined as LAB values, they can be used to come up with a better recipe each and every time. But that's only part of it. You need to define the spot color properly. Here I've got my favorite red, and I've got the color type as process, and I've got it specified as an RGB value here in Illustrator. And if I save this as the proper PDF file and bring it into my RIP, notice on my spot color panel, I don't have a spot color. Where's my favorite red? Well, it doesn't appear because I saved it as a spot color. I need to save it, my favorite red, as a spot color. Now here I have it saved as a CMYK value, and if I bring this in, there is my favorite red as a spot color, and there is that same CMYK value. And I can modify this, or I could use the LAB value that I have added to the RIP to make the best formula, the best recipe it can for the output device. So for spot colors, you want to make sure they are specified as spot colors, not process, in your application. You also want to make sure the RIP is configured properly to honor embedded spot colors. Okay, so proper file format, proper software, proper image resolution, and spot colors defined as spot, not process colors, and make sure your RIP is set enabled for use of spot colors. Well, specialty inks actually are kind of treated the same way. Specialty inks really are just a different kind of a spot color. Here I've got a document, and there's white ink specified for the document. I also have a spot color, the little bottle outlines here, and you can see on your monitors, hopefully, that's Pantone Process Yellow for the little bottles, and there's my white ink. The white ink needs to be named correctly. For the Fiery XF RIP, it's white_ink is the proper naming definition in order for the RIP to recognize that that's supposed to be using the white ink on the inkjet printer. Okay? There's my Pantone Process Yellow. And if I bring that file in, there's my Pantone Process Yellow, and there's my white ink. And notice they were recognized as that yellow color and the white ink. So the white ink will use the white ink designation will use the white ink from the inkjet printer, and the RIP will use the formula from the library for Pantone Process Yellow to try to come up with the best recipe for that yellow. Now, when you're creating this file and designating the white color spot color, the color you select and the solidity is only to help the designer creating the graphic. Okay? It's not going to print this light blue at 50% solid. That's just to help you design. I could say, well, it's going to be a dark blue. Well, guess what? If it's named properly, it's still going to use white ink. How about solid? Well, it might be a little more difficult to draw this if I can't see through it as I'm drawing, but still, this doesn't impact how the white ink prints. Okay? What if I change the name? Metallic ink. Now, simply changing the name to metallic ink, and if I save this, here's my PSD file with layers enabled and my spot colors. If I save this and bring this into my RIP, notice I've still held the process color, and now it will use metallic ink if it's available on my output device. Okay? And it's going to use the metallic ink even though it was listed as a solid reflex blue for the color for while I was drawing it. Now, if I use a tint of that color when I'm drawing it, the RIP would honor that. So you can use tints, but that's when you actually create that portion of the file, not when you just define the spot color itself. That's just to help you see when you're building it. Okay? So proper file format, resolution named as spot colors, and specialty inks named correctly as spot colors also. Get the correct name, find out from whoever is running your RIP or doing the production what name they want. It's kind of like at EFI, we are Pantone's, I believe, #1 customer. All our software is Pantone compliant. And that means the name has to be something like Pantone 250 coded, or C. A lot of people use the shorthand PMS from the old Pantone matching system. Well, Pantone never said that that's okay, and we actually aren't allowed to use PMS as a shortcut to the Pantone library. So if someone designates a color PMS 200C, that will come in as an unknown spot color. Okay? It should be Pantone 200C. Same thing with specialty inks. Is it white underscore ink, underscore ink, metallic, metallic ink, all uppercase, all lowercase? Find out ahead of time. Okay, full gamut printing. Now, not wide gamut printing. We were calling this wide gamut printing for a while, but the folks at the Idea Alliance are actually working on expanded gamut printing or wide gamut printing for traditional printing presses, running inks to higher densities to get more color, to be able to get snappier output and get more spot colors accurately hit with a 4-color press. Full gamut printing doesn't match the press. It tries to make use of every drop of ink available on that output device. This is what it looks like, and I go into a little more detail on this again in the previous color sessions, but expanded gamut printing here, you can see, rather than trying to match ISO coded, I can use more ink and actually get more snap, more contrast out of this. Now, this likely won't match the brochure, but why does it have to? Why should the display suffer because we're limited to what the offset printing press can print? Here's a red that's printed using traditional methods, and if I use expanded gamut printing, instead of my red being converted to a certain formula of magenta and yellow using an ICC profile, it's going to use all the magenta and all the yellow and get a much more vivid red. So that's kind of what's going on here in the background. Okay? If you want to do full gamut printing, the ideal is to keep your images in RGB color space. That's going to mean that the least amount of color is thrown away when it goes to your inkjet printer. Vector elements could be CMYK or RGB. Save it as a PDF X4 file. configure the RIP properly. That means it needs to be gray balanced. You're going to have to get someone involved that understands the G7 process or a different gray balancing process. And again, remember, this will not conform to a standard. You won't have the capability of measuring a color bar and getting a pass-fail to ISO-coded or FOGRA 39 or Grackle. Okay? So we've got the proper file format and resolution, spot colors and specialty inks defined properly as spot colors, and if I'm doing full gamut printing, I've had the files prepared and the RIP configured in order to take advantage of that. All right, how about cut paths? Well, it's the color, not the name, but in a way it still is the name. Let me show you. Here it's one of our little illustrations we use when we're demoing cut paths. It's one of our little cartoon characters. And you see I've got a cut path here, and it's named, the cut path is named cut contour. I've assigned it a color. It's a process color. It's a light blue, so I can see what I'm doing when I'm drawing it. I save this out, PDF X4, bring it into my RIP. No cut path, no spot color. What's going on? Again, even though I had the cut path named the type of cut I want to do, the color was wrong. RIPs look traditionally at the color of the path, not the name of the path. So let's go back and fix it. Okay? Well, I can do the bounding box, but I don't want to. I want to do the cut path. If I go back into my illustration, I don't care what the path name is. If Mary is creating the cut path and she wants to call it Mary so everybody knows that she's the one that drew it, fine. I have no problem with that. The color has to be defined as a spot color. Any formula named the type of the cut that you want to be created that the cutter supports. Kiss cut, crease cut, die cut, cut contour. If that is saved out as a PDF X4, then it comes in with the proper cut contour name. And on the cut panel, this is the cut panel on our Fiery XF RIP. You can see now instead of a bounding box, it does recognize the cut contour and it will treat that cut line correctly. Not print it if I don't want to and extract it to be sent to the cutter. So again, everything's fine so far. And for the cut path, assign the correct spot color name, not the cut path name. Be very, very careful. Those are probably the two biggest areas where we have problems. People say, it's not recognizing my cut path. That's because they either assigned it a cut path name but not a cut path color, or the cut path color was specified as process and not spot. The same thing for spot colors. They go, the spot color isn't reproducing right. We take a look at it and go, there is no spot color in this PDF file. You've converted it to process. Okay? Fiery XF, any of our RIPs can't modify or make use of a spot color definition if it doesn't see that there is a spot color. So preflighting, a good way to check the files before you send it to the printing company or when you get files in. Highly recommended. Now, even in something like Acrobat, you can go to Tools, and there's a Print Production option. If you go in there, let's take a look at our little cartoon, and we can see, oop, there's my cut contour. I've got a spot color called cut contour. I can now be confident that my RIP will honor that, pull the cut path out, send it to my cutter. How about if I look at this document? Uh-oh, no cut path. It's not going to honor it. It's going to wind up getting printed, or it's going to, possibly the document will fail, depending upon how I have things configured. So even preflighting in Acrobat, you can catch a lot of the problems before they get to the RIP and cost money because you've printed something, spent time, spent material, spent fairly expensive ink, and finding out that things weren't created correctly. Pit Stop, another product that a lot of people use for preflighting. You can do a lot of automation. You can even have it fix problems as it goes. The same holds true with Acrobat. But this is the kind of panel you do not want to see. It's set up to see if we're set for PDF X4. This is what you're going to want to see. But it's nice. You look at these documents that are created, and you can start to help train the content creators to make sure that they understand what needs to be done to create proper files so that they do print correctly for specialty printing. That it's the right format, resolution, names are correct, and passed our pre-flight checks. What if it doesn't? Is there anything we can fix? Well, there are some things we can fix. For instance, here, maybe I didn't have the name correct. Maybe for my RIP, it should have been 2 words with a space in between or a hyphen or an underscore. Well, if I check that box in Fiery XF and re-preview, I can force XF to use that color. Now, if it wasn't defined as a spot color, that I can't fix. That I'd have to go back to the original document and fix that. Okay? Even spot colors. Oh, that wasn't supposed to be processed yellow. That was supposed to be maybe a red color. Well, I can convert that to red. Again, if it's named as a spot color. Okay? Resolution, I really can't fix that by the time it gets to my output device. If you don't have the right resolution, boy, there's nothing I can really do for it at that point. Okay? Spot color, same thing. Make sure it's named correctly as a spot color channel, not as process. That I can do tons of changes in my RIP to modify the color and try to make sure it's exactly what you're going to want to see on the output device. Even color adjustments for my files. I can use the sliders. If you're on version 6.2, we removed the limitation that this would not work if your image had spot colors or if your document had spot colors in it. So might be a reason for you to upgrade to 6.2 if you haven't, is that these sliders will now work with anything where I can modify the overall color balance and contrast, brightness, saturation, do a little sharpening on my images. And again, maybe save having to go back into the original package or send it back to the content creator and waste all that time. There are ways to prepare or to check and see if your RIP is set to handle the output, especially the PDF X4. There's something called the Gamut Output Suite. We've got a link to it on our resources coming up. And you can print either the entire 4 pages or even just individual panels. You could select, for instance, 1 panel here and print that. And once it's printed, this is what you want to see. No X's. Anywhere there's an X, that means that the RIP does not support that particular method of transparency. For example, in this, it's not supporting any of the methods of transparency. Here, which is what you want to see, it's supporting all of them. So you can set up a workflow, process the Gamut suite, print it, and as long as you don't see X's or any of the other issues that the documents show that you should not see, you know you should be fairly confident that you're good to go to process your files that were done in the right format, saved at the right file type, images have the proper resolution, names correct for spot colors, for specialty inks, full gamut printing. Take advantage of that if you can. Again, take a look at the prior color sessions to get more information on that. Cut paths assign not the correct name for the cut path, but the correct color. Pre-flight your files. Make sure they're correct before you send them out. Don't waste time by sending out a file and hoping it's going to work. Don't waste time by bringing in a file and simply sending it to the RIP and hoping it's going to print correctly. Do some pre-flighting. Fix them if you can. And again, test the RIP so you're confident that you have the correct settings so that you can accept these files, process them and print them, and get the correct output for all your specialty printing needs. Carrie, back to you.
Thank you, John. As always, that was extremely informative. So to recap on what we learned today, we learned that knowing where and how your printed products will be used really does and should dictate the file preparation stage to achieve the best results. We also learned that preparing files correctly gives you more choices and flexibility downstream when working with files in your RIP and workflow software. Plus that there are tools available to test your output solutions for PDFX compatibility and how to spot file issues and how and where you can correct these. If you'd like to learn more, we have some resources for you. As John mentioned, we have the Gamut Output Suite for testing your output solutions for PDFX compatibility. We also have a document that can take you through how to use that Gamut Output Suite on a Fiery Pro server or Fiery XF to guide you to the correct settings. We also have John's resolution calculator spreadsheet for optimal file resolution for your output files, and we also have a tips and tricks document for working with white ink in Photoshop. And finally, we have the EFI knowledge base where you can find a selection of documents on cut, contour handling, spot color use, and more. So today was our first session in the World of Fiery wide format production series. Next in this series, on October the 21st, we have job layout and cutting options inside Fiery XF. On this session, you'll gain a comprehensive understanding of the job layout capabilities and cutting options available for Fiery XF and Fiery Pro Server. Then on November the 11th, we have Fiery XF's layout option. This option provides advanced tools for more sophisticated job layout above and beyond the built-in functionalities of Fiery XF and Fiery Pro Server. And John mentioned the colour series. If you missed this or wish to revisit any of the sessions from the wide format colour series, the PDF that you'll receive at the end contains links to those previous recordings.
All right, so we are almost at the top of the hour, but we do have some questions that we'd like to get to. So with your permission, John and Carrie, I think we'll go over a few minutes, 5-10 minutes, depending on the number of questions that we have. Try to get to most of them. As Carrie mentioned, I'm giving John and Carrie an opportunity to look through the questions now. So reiterate some of the information we went through earlier. We'll get back to you with information as far as the recording of the session, the full Q&A, and all the documents and resources that Carrie mentioned within a few days. So look for that in your inbox. And then if you have questions, this is the time to submit them. Carrie, should we start?
Yes. Okay, John, so today you mainly spoke about inkjet technology. Do any toner devices have specialty inks?
Yes, actually, some of the more and more the toner output device manufacturers are realizing that they also could add capability to use expanded gamut, either specialty color toners to expand the gamut, or white, clear, metallic. So the file preparation techniques that you need to do for inkjet printing that has any specialty ink actually as part of the output device, the exact same rules hold true from resolution, file preparation, naming of spot colors, naming of these specialty ink channels, exactly the same need on the toner side, and PDFX4 will be your friend on that side also. So yes, same exact rules hold true.
Okay, thank you, John. If I need to scale a low-resolution image, what are the best settings to use? For example, a screenshot.
Well, the best settings to use would be to recreate the thing with the right resolution in the first place. The problem is that you can never make more detail. If you have an image, for example, that has someone's head with one strand of hair, and you scale him up much larger, he's not going to have a much fuller head of hair. Trust me, I've tried it. It doesn't work for me. Okay, it won't create more detail. The best resolution set, or the best setting you could have in something like Photoshop would be bicubic as the choice. Bicubic does additional sampling around each pixel. In a simple scaling, let's say you have a black pixel right next to a white pixel, scaling doesn't make those pixels bigger, it just spreads them apart and adds pixels in between them. So if you spread them apart to give one pixel in between the black and the white, in a simple scaling, it would just simply make a 50% gray pixel. But in bicubic, it might not only come up with a different color for that pixel, it might actually change the black and the white pixel so that the document looks better, less grainy, less stair-stepping. So bicubic interpolation is your option. You can go into your manual to find out where you would set that in the various applications. Years ago, there were specialty products that people would use, like fractals, I remember, was a product a lot of people said that was even better than bicubic interpolation, although bicubic interpolation has also been improved over the years. So you can try that, but keep in mind it's not the cure for not having the correct resolution in the first place.
Okay, thank you, John. Next question is, do all RIPs have the ability to manage spot colors and paths as you demonstrated today?
Well, if you buy them from EFI, they do. However, no. There are a lot of RIPs out there. There are a lot of fairly simple RIPs. There are even RIPs you can download for free and one notably that a lot of photographers use strictly for printing black and white images on, for instance, Epson printers. There's a popular rip out there. That doesn't have any of these capabilities. The higher end rips that you would get from companies such as EFI, if they're geared towards the world of production, then yes. If you find a very, very old copy of the rip even from EFI back in the days when, hey, it was only proofing, we didn't do production printing on inkjet printers. Those old rips were not capable. They didn't recognize any cut paths or necessarily specialty inks. They could recognize spot colors even if they were only proofing rips. So you might be safe there. But you might be better off either certainly upgrading to the current versions of your RIP or purchasing a RIP that does understand the world of specialty production printing.
Okay, next question is, TIFF can also be saved with layers. Are they not supported the same by the RIP?
Not necessarily. I've run into just some problems. I find PSD just for whatever reason just seems to work better. TIFFs on different RIPs I've tested, not necessarily EFI, it just caused problems. PSD just seems to be, you know, I don't know, a kinder, gentler file format for some reason or other. I think maybe just some of the RIPs just haven't caught up.
Okay, thank you. And we have a question here that I can answer. So, how do we get access to previous presentations? So,
call me up, I'll come over to your house.
Good answer, John. So yes, whichever invite you received, the location, the landing page or the web page that you went to register also shows the recordings of the previous wide format series. So visit that. Also, the PDF that you receive after the presentation has live links also to those recordings. So 2 answers to that one. So we have another question for you, John. Is it a general rule not to convert spot colors to CMYK or RGB color builds when going to press for regular brochures that you intend to print only process?
Well, if you know you're going to print it on a press and you know you're going to convert it to CMYK, then because it has to be converted to CMYK for the press, then I would say yes, you want to convert it to CMYK. But now we're back in the world of proofing. You want to make sure that then you don't proof with the named spot color, because your RIP might give you a better match, a more close match to the true, say, Pantone or Toyo or HSK color than the press is going to hit. So in that case, you want to make sure you do convert or specify a CMYK that you proof exactly the same file as is going to go to press so that you don't get that mismatch.
All right. So we do have a couple more questions, but I do want to respect everybody's time, both our presenters and our audience. So if we didn't get back to you right now with your questions, we apologize. We will get back to you personally via email. Make sure you get the answer to your question. So with that, I want to thank our audience for joining us, our lovely presenters for being here today and imparting all this great information. You will get a follow-up email within a few days with all the wonderful information available to you, including links to previous sessions. So look out for that. And we hope to see you in 3 weeks when we have the next session. So with that, have a great day. Take care.
Thanks, everybody.